Hello friends. So I started the very first class of my new grade 7 students with this following question. I asked them to describe one question about this world that you have asked your parents which they could not or did not explain satisfactorily, and so you are still wondering about it. Now why did I do that? I feel that when my students have come to the physics class, the very first thing they should know is how to ask questions. When they are young, they all have this knack of asking questions, the knack of looking at the world, observing it keenly, and then wondering and asking why it happens, how it happens. But as they grow up, as they go through the school system, somehow they tend to lose this habit of asking questions, and hence their curiosity starts dying and their hunger for learning also starts to die. So I want to reverse this process. I want to prevent this process. So I'm hoping that with this batch, let me see how this new experiment works. So I got them to fill up this Google form, and I've got a lot of interesting questions. So I thought that I should make a video answering all of them so that in the next class I can continue the discussion with some more new questions. The first question says, why does an iron nail of so less mass sink, but a heavy ship made of iron easily floats on water? So he is comparing an iron nail of mass, say 5 grams, and a ship of mass, say 5 tons. So he thinks, how can the water surface support 5 tons when it can't support even 5 grams? So it's a very normal, natural question. So you need to understand the concept of buoyancy, which obviously they haven't studied yet in grade 7, very first class of physics. But then by asking this question and speaking further about it, he exposed one misconception which he has gained after attending my first class. So in the first class, when we were discussing about the concept of pressure, I had explained that if the area of contact is small for the same force, the pressure is large, and if the area of contact is large for the same force, the pressure is small. So this boy has applied this concept in the wrong way to understand this, to apparently understand the answer. So let's read what he says. He says, this question did baffle me until the first physics class yesterday. Although in both cases there is a nail and the ship, the mass volume ratio, there is density is the same. So now what he's saying is the ship is made of say iron, and the density of iron he has calculated. But actually what he needs to do is calculate the effective density by incorporating the volume as made up of even the empty space inside the hollow ship are making up the volume of the ship. Not just the actual volume of the material of the ship, but instead the volume of the space occupied by the outer layer of the ship, the boundary of the ship. So if the ship had not been hollow, if it had been solid iron, then obviously it would have sunk just like the nail. The only reason the ship doesn't sink is it is hollow. So its effective density becomes less than the density of water because it is hollow. So he has rightly understood that both the ship and the nail have the same density of iron. So he has ignored the effective density concept here. And he's saying that there is only a very pointed area on which force applied by the nail acts. And thus there is high pressure when the nail sink. But in the case of the ship, there is a huge area, there is less pressure acting on the water, making it float. So the mistake here is the base area of the ship is larger than the base area of the nail. But then the weight of the ship is also way much larger than the weight of the nail. So overall the pressure exerted by the ship will be actually more than the pressure exerted by the nail. So this logic of pressure is not going to apply, is not going to explain why the ship floats. So instead of going in more detail to explain about density, that will do. I think it's better to tell him to wait for the density class to understand why a ship floats while an iron nail sinks. Okay, so that's why you have to be more attentive in physics class. We'll be soon covering this when we learn about Archimedes principle, buoyant force, and density in more detail. So let's move on to the next question. Why does the ball stop rolling when I throw it? They told me about friction. That friction always opposes the motion of the moving object. It did not clear my doubt and I still wonder about it. Well, I spent the whole of last class explaining this. So are you still wondering about it? So the answer given by the parents is of course wrong. Friction doesn't stop a ball from rolling, it actually helps the ball to roll. If there was no friction between the ball's the surface and the floor, the ball cannot roll, it will just slide, it will just skid. So friction helps the ball to roll. So let me explain this better with the help of a diagram. So this is the flat surface of the ground and this is the ball. When it rolls, the point of contact of the surface of the ball with the surface of the floor is actually at rest. It doesn't slip. So the friction makes sure that the point of contact of the ball and the point of contact of the floor, they do not slide over each other. They remain in contact without slipping. So what happens? The next neighboring point gets in contact and this goes up. So like this, next this point will get in contact, next this point will get in contact. So as a result, the ball rolls. So as it rolls forward, a new point comes in contact with the floor. And whichever point comes in contact with the floor does not slide on the floor. It just stays in contact, at rest on the floor. And then a new point will again come in contact with the floor. So friction makes sure that the point of contact do not slip across each other. So friction is responsible for making the ball to roll and not to make it stop rolling. So then what makes it to stop rolling? It rolls because no spherical object can remain spherical when it is placed on a flat surface. Because every spherical object has weight. And if it's a perfect sphere, the area of the point of contact with the ground would become how much? It will become a single point. So it will become zero area. And whatever weight it has, if you divide it by zero area, the pressure you get will be infinite, which is practically not possible. So the moment you start with this perfect spherical shape and place anything on the ground, the huge pressure will cause it to deform. So it will become, the point of contact will become flat and the rest of the thing will be spherical as before. So now the area is no longer zero, it is some small value. Let us say small a. So now the new pressure will be the whole weight of the spherical object divided by the small area, which will give you some finite value of pressure. So due to this pressure and due to the fact that there is this flat surface here, if a spherical object is trying to roll on a flat surface, what will happen? So if it's like this, so some energy is being lost in deforming the shape of the ball. So whenever you press a ball, you need to exert a force, use up some energy to do that work, by deforming the ball. So the kinetic energy of the ball, which was originally present in the form of rotational kinetic energy or translational kinetic energy, some of that kinetic energy is used up to deform the ball, and then when it deforms, the molecules of the structure or material of the ball, they rub over each other, producing some heat. So some energy is lost as heat to the surroundings. So as the kinetic energy decreases, the speed also decreases, so the ball starts to roll slower and slower and slower. And one more reason why it slows down is, if an object is trying to rotate, but this is flat, so the ground will exert a normal contact force. It will push in this direction. So if something is trying to roll like this, but from outside the ground is pushing it in the opposite direction, like this, so it will create a rotating force in the opposite direction. So this is called rolling resistance. This is not friction. It is called rolling resistance. It opposes the rolling motion. Is it clear? I hope so. So let's move on to the next question. Why does Earth exert a strong gravitational force? So this is a very deep question. Isaac Newton first answered it in a, what do you call it, in a simplistic manner, and then Einstein gave a much more better explanation. So Newton simply said that any object, if it has mass, it will create a gravitational field in space around it. This field is something which is invisible, which we cannot see, and this field will exert a force on any other object which has mass. And this field is always an attractive field. So if you have two masses which have some which are separated by some distance, they will get attracted to each other. The field of the first mass will attract the second mass. The field of the second mass will attract the first mass. So both will get attracted to each other. This is Newton's law of gravitation. Now what Albert Einstein said is, he said that any object which has mass will deform the space-time around it. Space as well as time. Everything is getting deformed. And as a result, any object which was originally trying to go straight, when it ends up traveling through this deformed space, it will end up curling around the heavy object. So that's what we see as, that's what we perceive as if the heavy object is attracting the other object with some force. But actually it's not attracting, it has just deformed the space itself, so that any object which wants to go in a straight line ends up going in a curved path. The next question. What will happen if a place is completely empty and does not even have air in it? Well, that is called vacuum. And even though you have a perfect vacuum, there is still energy in that space. And from that energy, as long as the Heisenberg's uncertainty principle is not violated, in a small enough time interval, any mass particle can also be created. And then it will get destroyed before that time interval elapses. So that is something you can explore further. Heisenberg's uncertainty principle, energy, time, uncertainty. Next, ask my mom that if someone dies, why can't they come back? She gave a simplistic answer, it's the rule of nature. Well, let me see how can I answer this. This is, yeah, it is a law of nature. It's one of the noble truths, 4 noble truths which Gautama Buddha said. One is that there is suffering. You have to undergo suffering. If you have a body, if you have a life, you have to undergo suffering. Second noble truth is you will die one day. What is the third noble truth? Okay, this also you can Google up. What are the 4 noble truths? But one of the noble truths is that anything which is living has to die someday. I think I may be wrong, just check it out. Okay, now why can't they come back? Well, then this question doesn't come under physics, because what makes an object or a being living instead of dead is something called as consciousness, and consciousness cannot be detected by science as yet, so it doesn't come under the purview of science. So if you leave science aside and try to answer it, then I would say that there is something called a soul which makes a body come alive, and when the soul leaves the body, the person is said to have died. This is basically like one theory. You can accept it or you can reject it. It's just a model to explain what is happening. Right now we don't have any experimental proof to claim that this is true. If you have a better explanation, go for it. So now after the body is, something is faulty with the body, that's why the soul left the body. So if it has to come back, we call it as rebirth. So it will again choose a new body and the home of a baby. So this is just one theory, okay? You can discard it anytime, or you can reject it outright. This is what I think as a plausible explanation. So that's how, when a new baby is born, that soul which enters the new baby would have had a past life before it was born in this new baby. So that's how one way we explain child prodigies. So they have acquired so much skill in the past life that some of it carries over in the next life also. This is just a hypothesis which I have. May be true, may not be true. Okay, next question. When a bulb is lit, it gets hot, and when a tube light is lit, it doesn't get hot. Why? Good question, good observation. So the technology behind a bulb and a tube light is different. Tube light, it glows using a principle called fluorescence, and it's a discharge tube, whereas a bulb, you are referring to a filament bulb, not the white ones, which is also a fluorescent bulb. So the filament bulb glows because when current passes through a thin wire, the resistance of a thin wire is very large, so it produces a lot of heat in addition to light. So while producing light, it becomes red hot, white hot, and then produces light. But it also produces heat. Whereas a fluorescent tube, it has inert gas inside which, when ions are passing inside an inert gas atmosphere, they bombard with the inert gas and excite the electrons to higher energy levels, and when those electrons come back to the lower energy levels, they give out the excess energy as light. In fact, ultraviolet light. Now the inner walls of the glass tube of the tubelet is coated with a fluorescent material which absorbs this UV light and then re-emits it as visible light. So this is very efficient compared to the bulb, filament bulb. So electrical energy is more percentage of electrical energy is converted into visible light in a fluorescent bulb, fluorescent tube light, rather than a filament bulb. So that's why we use it, and we say it conserves electricity. Where does the moon follow us when we drive in a car? Very nice question. I also used to have this question when I was a small child, and I used to see how come the moon is always following me when I'm going in a car or in a train. So I wonder why your parents did not answer this. It's a very easy question to answer. The reason is that the moon is so far away that whatever distance we travel, it is nothing compared to the distance at which the moon is right now. It's the same reason why stars seem to be the same place no matter where you go. Just do this experiment. Keep something very close to you and start walking while looking at it. It will move very far away. It will start moving back very quickly. Now go a bit away from it and then continue walking same way. say walk 5 steps every time. Now you will find that it seems to have gone back less. Now go as far away from it as possible and again travel 5 steps. Now you will find that it doesn't seem to move at all. So a more detailed explanation will be in terms of geometry, but we will not go into that right now. If you want, you can try and figure it out. Okay. The student says he has cleared all my doubts. That's not a good sign. How can you have no doubts? How can you have no questions when you are in grade 7? The principle on which rockets are launched. Well, rockets are launched on the same principle in which, okay, you can test it out. Take a balloon, fill it with air, and then don't close the end through which you filled in the air. Just leave the balloon. You'll find that as the air escapes from the balloon will go in a random manner, fly all over the place, all over the room. So it's the same principle. When the air is getting pushed out of the balloon by the contracting rubber membrane of the balloon, by Newton's third law, the air molecules will in turn push the surface of the rubber membrane in the opposite direction. So it moves. So in your rocket, you just make use of this principle in a very controlled manner so that the rocket doesn't go in a random manner, but it goes in a straight line or in a controlled manner. Why does time flow in one direction? Well, if you ask me, time is not a liquid or some object which flows. Time is a concept which we use to measure the rate of change. So if nothing was changing around you, you would have no way of measuring time. Time is a very, very, very deep and subtle concept to understand. So there are 2 layers of understanding time. One is the classical way of understanding time, the way Newton in classical physics understands time. And that way is, we think that time flows at a constant rate, like we define something like seconds, minutes, hours, years, months, days. So how do we define this rate? We define this rate using something which happens using something which changes at a steady rate, which is like anybody who checks the rate of change of that phenomenon, they will get the same rate always. That is used to define time, unit of time. And using that small fundamental unit of time, we define time itself. So for example, atoms which are vibrating, they tend to vibrate at a certain rate. So that could be used. Or the frequency of light could be used as a measure of time also. Frequency of a particular wavelength of light could be used as a unit of time. Something like that. Any phenomenon which happens at a fixed rate in nature, always, no matter who observes it, when he observes it, can be used to define time. But in the absence of that phenomenon, and if nothing is changing in space around you, then you have no concept of time. Now, Einstein again came up with a special theory of relativity in which he came up with a new concept called space-time. So space-time is different from time. Space-time is a concept which links space, that is the 3D space around us, and time together into some new concept. It's still very confusing and I'm unable to wrap my head over it. So you need to look up or understand special theory of relativity to understand time in a more deeper level. Why do people cry when they laugh? Okay, this is a biology question which I would transfer to my biology colleagues. I am not so sure. What happened before the Big Bang? So the Big Bang theory, according to that, During the Big Bang only space, this whole fabric of space-time got created. Space-time means space and time are connected together. The concept of time is separate from space is not actually correct. So you can't ask before the Big Bang what happened. Because before the Big Bang there was no time, there was no space. So it's an invalid question. Why ocean's water is salty? For this there is a theory that whenever it rains, okay, or when the snow on top of mountain peaks, when they melt, the fresh water originally doesn't contain any salt. Rainwater also doesn't contain any salt. But when they flow in the form of rivers and finally dump into the oceans, during their long journey over the land, they dissolve all the minerals and salts present in the rocks and in the soil and dump it in the ocean. From the ocean, the water evaporates, leaving behind its salts and minerals. And so, over thousands of years, ever since the planet Earth has been found, this water cycle has been happening. And the salts which got dumped in the ocean have nowhere to go. So they have been accumulating there for these thousands of years. So it has become so salty. So 1,000 years hence, it will be even more salty. And it will become inhabitable for sea animals, or it may lead to evolution of new forms of animals which can live in such a highly salty water. So already there are some seas like the Dead Sea, which has so much salt content that it is a dead sea. No animals can survive in that salt content. Okay, I have covered all the questions of my class. Hope you enjoyed the video. See you in the next video.